The National Electrical Code, specifically Article 334.23a, prohibits running conductors or cables within 1.25 inches of the finished surface of walls or ceilings, unless approved methods are used. However, Article 334.23b allows running conductors or cables within 1.25 inches of the finished surface of walls or ceilings if certain conditions are met. Firstly, they can be enclosed in metal conduit, electrical metallic tubing EMT, or intermediate metal conduit. Secondly, they can be installed in a raceway. Thirdly, they can be protected by a metal plate at least 0.40 inches thick. And fourthly, they can be run in the space between the framing members and sheathing. The International Residential Code, specifically Section R602.5, also addresses this issue, prohibiting running electrical wires within 1.25 inches of the finished surface of drywall or other wall or ceiling coverings. There is an exception, however. Firstly, wires can be run within 1.25 inches of the finished surface if they are enclosed in a ferrous metal raceway. Secondly, if they are installed in a concealed space. Thirdly, if they are run perpendicular to framing members at least 12 inches from the top or bottom of the wall. Based on these codes, it is generally not allowed to run electrical wires within 1.25 inches of the finished surface of walls or ceilings without meeting specific exceptions. Considering site-built or manufactured homes with drilled holes in wood planks, it seems unlikely that these installations would meet the exceptions outlined in the codes. Therefore, it is highly probable that this wiring method will present an issue in most areas of the United States. To avoid potential code violations and construction delays, it is recommended to install the wiring in a manner that strictly adheres to the code requirements. Acceptable methods include using conduit, raceways, or metal plates to provide the necessary protection for the wires. Now let us delve a little deeper into understanding these codes and how they relate to your specific situation. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Article 334 specifically addresses non-metallic sheathed cable, often referred to as Romex, which is commonly used in residential wiring. The 1.25-inch rule, as it is often called, is designed to protect the cable from physical damage. Imagine a scenario where someone is hanging a picture or installing shelving. If the wiring is too close to the surface, there is a risk of accidentally puncturing the cable with a nail or screw, which could lead to a short circuit, electrical shock, or even a fire. The exceptions listed in Article 334.23b are designed to provide alternative methods of protection. Enclosing the wires in metal conduit (EMT) or intermediate metal conduit provides a robust physical barrier against damage. A raceway serves a similar purpose, providing a channel for the wires to run through, protecting them from external forces. A metal plate at least 0.40 inches thick can also be used to shield the wiring. This is often used in situations where the wiring passes through a stud or other framing member. The International Residential Code, or IRC, is another widely adopted building code that covers various aspects of residential construction, including electrical wiring. Section R602.5 of the IRC mirrors the NEC in its restriction on running electrical wires within 1.25 inches of the finished surface. The exceptions listed in the IRC provide similar alternatives for protecting the wiring. The requirement for a ferrous metal raceway ensures that the raceway is made of a strong, durable material that can withstand physical impact. Installing the wires in a concealed space, such as within a wall cavity, provides a degree of protection. Running the wires perpendicular to framing members at least 12 inches from the top or bottom of the wall reduces the likelihood of them being damaged by nails or screws. In your specific situation with site-built or manufactured homes using stacked pine planks, the drilled holes in the planks are unlikely to be considered an approved method of protection under either the NEC or the IRC. While the manufacturer may consider these holes as conduit, they do not meet the definition of conduit as defined by these codes. Conduit, as defined by the NEC, is a rigid metal or plastic tubing specifically designed for protecting electrical wiring. The holes in the wood planks, while providing a channel for the wires, do not offer the same level of physical protection as conduit. Therefore, simply running the wires through these holes would likely be a code violation in most jurisdictions in the United States. Now let us talk about possible solutions. Firstly, consider using conduit. Installing a conduit system within the walls would provide the necessary protection for the wiring. This could involve running individual conduits for each circuit or using a larger conduit to accommodate multiple circuits. Secondly, think about using a raceway system. There are various types of raceway systems available that could be used to route the wiring within the walls. These raceways are typically made of metal or plastic and provide a channel for the wires to run through. Thirdly, look into using metal plates. If it is not feasible to use conduit or raceways, metal plates could be used to protect the wiring in areas where it is close to the surface. These plates would need to be at least 0.40 inches thick and securely fastened to the framing members. Fourthly, consider stick framing. While the manufacturer may not be happy with this solution, creating traditional stud wall cavities would allow for the wiring to be installed in accordance with the code. This would involve building a frame within the walls to create a space for the wiring to run. It is also important to consult with local electrical inspectors. Electrical codes can be interpreted differently in different jurisdictions. Consulting with local electrical inspectors is important to ensure that the wiring installation meets all applicable requirements. Be prepared to provide the inspector with detailed information about the wiring methods you plan to use and be open to their suggestions. Getting approval from the electrical inspector before starting the work can prevent costly rework later on. By understanding the requirements of the NEC and IRC, and by working closely with local electrical inspectors, you can ensure that the wiring in these site-built or manufactured homes is installed safely and in compliance with all applicable codes. This will not only protect the occupants of the homes but also avoid potential legal and financial repercussions. Let us also consider the practical implications of these code requirements. Imagine you are an electrician tasked with wiring one of these homes. You carefully run the wires through the pre-drilled holes in the wood planks, thinking that this will save time and effort. However, when the electrical inspector arrives, they immediately flag the installation as a code violation. Now you are faced with the task of redoing the entire wiring system, which will cost you time, money, and potentially damage your reputation. On the other hand, if you take the time to understand the code requirements and install the wiring properly from the beginning, you can avoid these problems. You can choose to use conduit, raceways, or metal plates to protect the wiring, or you can opt to create traditional stud wall cavities. While these methods may require more time and effort upfront, they will ultimately save you time and money in the long run. Furthermore, by adhering to the code requirements, you are ensuring the safety of the occupants of the home. Electrical fires are a leading cause of property damage and injuries in the United States. By installing the wiring properly, you are reducing the risk of an electrical fire and protecting the lives of the people who will be living in the home. In addition to the NEC and IRC, there may be other local codes or regulations that apply to the wiring installation. It is important to research these local requirements and ensure that the installation complies with all applicable codes. For example, some jurisdictions may have stricter requirements for the type of wiring that can be used or the way that it must be installed. Understanding these local requirements is essential for ensuring a safe and code-compliant installation. Now let's address some common misconceptions about electrical wiring. One common misconception is that as long as the wires are insulated, they are protected from damage. While insulation is important for preventing electrical shock, it does not provide adequate protection against physical damage. Nails, screws, and other objects can easily penetrate the insulation and cause a short circuit or other electrical problems. Another misconception is that low-voltage wiring does not need to be protected. While low-voltage wiring is not as dangerous as high-voltage wiring, it can still be damaged by physical forces. It is important to protect low-voltage wiring from damage by using conduit, raceways, or other approved methods. It is also important to use the correct size and type of wire for the application. Using undersized wire can lead to overheating and potentially cause a fire. Using the wrong type of wire can also create safety hazards. Always consult with a qualified electrician or electrical engineer to determine the correct size and type of wire for the specific application. Electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on any electrical wiring. Use insulated tools and wear appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Remember, safety should always be the top priority when working with electricity. In conclusion, while the idea of using the pre-drilled holes in the wood planks as a conduit for electrical wiring may seem like a convenient solution, it is unlikely to be compliant with the NEC, IRC, or other applicable codes in most jurisdictions in the United States. To ensure a safe and code-compliant installation, it is important to use approved methods of protection such as conduit, raceways, or metal plates, or to create traditional stud wall cavities. By understanding the code requirements and working closely with local electrical inspectors, you can avoid potential problems and ensure the safety of the occupants of the home. Let us consider some hypothetical scenarios to further illustrate the importance of code compliance. Scenario 1 involves a homeowner who decides to install electrical wiring themselves without obtaining the necessary permits or following the code requirements. They run the wires through the pre-drilled holes in the wood planks, thinking that this will be sufficient. A few months later, a fire breaks out in the home, caused by a short circuit in the improperly installed wiring. The homeowner suffers severe injuries and the home is extensively damaged. In this scenario, the homeowner's decision to disregard the code requirements had tragic consequences. Scenario 2 involves a contractor who is hired to wire a new home. A contractor is aware of the code requirements but decides to cut corners to save time and money. They run the wires through the pre-drilled holes in the wood planks, knowing that this is not code compliant. The electrical inspector discovers the violation and orders the contractor to redo the entire wiring system. The contractor loses a significant amount of money and damages their reputation. In this scenario, the contractor's decision to prioritize profit over safety had negative consequences for both the contractor and the homeowner. Scenario 3 involves an electrician who is hired to wire a new home. The electrician carefully follows the code requirements and installs the wiring using approved methods of protection. The electrical inspector approves the installation, and the homeowner is able to move into the home with peace of mind. In this scenario, the electrician's commitment to code compliance resulted in a safe and successful project. These scenarios highlight the importance of understanding and adhering to electrical codes. While it may be tempting to cut corners or take shortcuts, the potential consequences of doing so can be severe. By prioritizing safety and code compliance, you can protect yourself, your property, and the lives of others. Let's also think about the long-term implications of code-compliant wiring. Firstly, it ensures safety. Code-compliant wiring reduces the risk of electrical fires, shocks, and other hazards, protecting occupants and property. Secondly, it adds value to the property. A home with properly installed wiring is more valuable and easier to sell. Buyers are more confident in the safety and reliability of the electrical system. Thirdly, it saves money on insurance. Insurance companies may offer lower rates for homes with code-compliant wiring. It reduces the risk of claims related to electrical issues. Fourthly, it reduces maintenance costs. Properly installed wiring is less likely to experience problems and require repairs. It saves money on maintenance in the long run. Fifthly, it ensures peace of mind. Knowing that the wiring is safe and up to code provides peace of mind. It reduces stress and worry about electrical issues. To stay up to date on electrical codes, consider firstly joining professional organizations. Organizations like the National Fire Protection Association (NFPA) and the International Association of Electrical Inspectors (I) offer resources and training on electrical codes. Secondly, attend industry events. Trade shows and conferences provide opportunities to learn about new technologies and code changes. Thirdly, subscribe to industry publications. Magazines and online resources provide updates on electrical codes and best practices. Fourthly, take continuing education courses. Many organizations offer courses on electrical codes and safety. These courses can help you stay up to date on the latest requirements. Fifthly, consult with experts. Electrical engineers and inspectors can provide guidance on code compliance. They can help you understand the requirements and ensure that your installations are safe and code compliant.